So Conamix has been around for 6.5 years. We have been developing what is a very low cost, high energy battery based on sulfur. Batteries take a long time to develop, and we've done most of the scientific or in the research on this, and we're at the point where about to where we're ready to commercialize and hit our first beachhead market. Um, the what's driving this company is that batteries are everywhere and in everything. At the end of the day, despite policies locally, globally, batteries are increasing in use as we electrify everything around us. Um, and it's a global race, and there's global competition. China, as everyone knows, leads the way with control of supply chains and the best technology to build batteries. If you think about it, it's not about labor at this point. It's about technology to make the batteries, and it is about the materials that go into them and the supply chains that support them. If we're going to compete in North America or Europe, we have to bring supply chains locally. We have to have a cost advantage, a leapfrog of the current battery technologies that are out there. You may be familiar with what's called lithium iron phosphate, LFP, and NMC. NMC is the C is cobalt. We've all heard and read in popular literature that's out there that there are supply chain risks associated with all those and volatility and prices that are associated with them. So at the end of the day, we have to make sure we're as low cost as possible if we're going to compete, and that we have supply chains that are local. Battery prices have been falling. This is something else to keep in mind. Battery packs are what go into the to auto EVs in particular, but it's a good marker for where prices are going. Packs are an agglomeration of battery cells that are made into modules that are then put into a pack. They've hit $115 on average, according to Bloomberg, per kilowatt hour, $115 per kilowatt hour, which is incredibly low. What's even more remarkable is that in China, using LFP batteries, there's reports that they've gone as low as $94 a kilowatt hour. It was just a few years ago that NMC batteries on a cell level were $94 a kilowatt hour. So these are remarkable numbers. Outside China, the cost remains to make them above $115 a kilowatt hour. To give you an idea of compete a car that's a EV compared to an internal combustion engine car, the point where it becomes cost neutral to have one or the other is around $100 a kilowatt hour. So getting sub 100 is the goal. The way you do that is you have to pick the right materials. And sulfur is a material that people have been looking at starting in academics about 60 years ago. And the reason you look to it is if you look at the periodic table, it's cheap. Lithium is prevalent as well, and sulfur is ubiquitous. So supply chain risks do go away, costs are low, and the potential for energy density that you can get out of the battery, or the amount of energy per kilogram that you would get, is much higher. The potential is much higher in sulfur. However, sulfur batteries are really, really difficult to make work well across a wide variety of conditions, and that's why it's taken so long to come to market. Conamix, we've taken a different approach than other people who've been in the field, and there have been several companies that have come and gone over the last decade in this area trying to commercialize sulfur batteries. But the approach that they've taken has been to solve top-level problems. And if you think about batteries, what you care about is energy, power, and cycle life. Cycle life is what has helped people raise money for their companies. And so they've solved problems in sulfur batteries to improve cycle life at the expense of power. And so we took a different approach. We focused on energy and power as the key to solving cycle life. And the important part here is that we didn't add anything to the battery to make sulfur, to move away from the value proposition offered by sulfur. Competitors that are still out there that we are aware of all use materials in their battery to improve performance in lithium sulfur batteries using very expensive materials. What's really hard about a lithium sulfur battery? It's a basic fact about sulfur is that it's insulating. It's insulating ionically and insulating electronically. And when you discharge a battery and you want to get the ions, the lithium and the lithium ions and the electrons back to the sulfur to create lithium sulfide in the cathode, you have a big problem because sulfur is insulating. You have to add things to it to make it more conductive. And people typically have added very expensive carbons, things like graphene and carbon nanotubes that are expensive, but are also non-contributors to the performance of the battery other than to give it ionic conductivity. So they're kind of dead materials otherwise in the battery. So we've taken a different approach, and what we've been able to do, if you remember that $94 was the price of a battery pack made in China, we've achieved a price point for a pack that's around $77. So it's roughly $20 per kilowatt hour cheaper. And it uses materials in the cathode in particular. The cathode price here is very, very low. It's one of the lower parts of our BOM, our bill of materials. And it's based on sulfur, and it's based on something that we actually do license from Cornell, an intercalation material, titanium disulfide. And titanium disulfide is also a commodity material, and it's made from commodity precursors. By doing so, we eliminate most of the carbon that all of our competitors use, and we have something that contributes not only to the energy component of the battery, but really helps us with power. Power is the ability to get the electrons and the energy out of the battery at a high rate. And sulfur, as you can imagine, because it's insulating, it's very difficult, and carbons do not help you do that. But the intercalation material that we have that's cheap allows us to do that. With a whole host of other innovations, we've been able to that work in concert with that intercalation material, including binder, electrolyte, and protective layers for the lithium. We're able to attack the problems in lithium sulfur batteries that put us in the position to really hit our beachhead market. What it's done is it's given us a battery that has more active material in the battery than our competitors do. It's higher energy density as a result. Lithium iron phosphate, LFP batteries are almost 200 watt hours per kilogram. NMC batteries are 280 watt hours per kilogram. And we've developed batteries that are over 500 watt hours per kilogram, albeit at the 1 amp hour pouch cell level at the moment, but scaling as we go. The key point here is that we have more power out of our material, so we can deliver energy faster. The market that we're going after, the beachhead market, is that we're going to go after a military market called loitering munitions and attritable drones. The modern warfare is going to is becoming drone warfare, and the fastest growing segment in that drone warfare market is and has been demonstrated is something called loitering munitions. These are single-use batteries, they're powered by single-use batteries that maybe have to charge once or twice, once to test the drone, and then a second time charged and then sent out on its mission. Everything in this field is about low cost and range. It's not just range and it's not only range, it's computing power that's on board of these drones as they use AI and other technologies to zero in exactly with precision on the targets that they're after. Attritable drones are drones that travel in packs and that are expected to be sacrificed over time. So they maybe only need 10 to 15 cycles, well within what we can do, since we can do over 100 cycles with our batteries. So these are very rapidly expanding markets. It's not often that you hit a market that is, let's see here, why isn't it moving? Trying to get to the next slide here. What you often don't see is a market that's rapidly expanding, that's nascent, and that does not have an incumbent. What they have is a great need for a battery that's lower cost than they currently buy, that provides greater range, and the technology that we have fits that bill. We're looking for $20 million of investment that supports outsourced production. To date, we've raised $24 million over the 6 years, which for a battery company starting from scratch is a ridiculously low number. We've used it obviously wisely, now we're talking about scaling using resources that are outside the company. It's a lean business model that leads to positive EBITDA in 2028. And revenue that increases fairly rapidly in this very rapidly evolving field. After break even, there's greater markets. There's two possibilities. We may be acquired, or we may raise more funds to attack really the large markets that are out there. That's the EV market that we were, when we initially formed, focused on. Those take longer. That's a bigger market to penetrate. There's a longer development cycle, even once you have the battery at scale, while the auto manufacturers put you through the paces of A samples, B samples, C samples, all the way to D and F, D, E, and F. And so that takes time, that takes energy, and so that's the reason for focusing on beachhead markets along the way. On the way to EVs, we'll probably be looking at micromobility markets. We're already looking at those markets, but probably begin to penetrate that market because, again, that's about low cost and high energy density for longer trips. And it would support models that are evolving right now in Southeast Asia that involve battery swapping for these modes of transportation. We're supported by investors that are knowledgeable. Volta is a premier investor in the energy space, VC space. They've been with us from the beginning. Fund called Hegemon as well has been there with us from the beginning. Catalyst, which is again another battery energy focused VC, and New York Ventures has been with us from the beginning. We license a very important patent for our technology from Cornell. We also have IP from University of Waterloo. We've done work for IARPA as well, and we have a relationship, a joint development agreement with a tier one supplier to the auto industry in Germany, and they have offices around the world. And that's the end of my talk, and happy to answer questions.
Thanks, Nabil. We'll try and take some to keep on time. But are you going to be around for the networking?
I will absolutely be around for the networking.
Good. Then I'll be sure. Yeah, just we'll try and keep the questions to just a couple of them, seeing you're going to be around.
How do I stop sharing the screen here? Let's see here. Present.
So, and any questions? Lavina, I see you've hopped up onto stage. I don't know if that was intentional or you...
No, sorry. I think that was from the last session I was on, that I was on stage. So let me turn myself off.
All right. So any questions from any of the audience?
Okay.
All right. Well,